The Krebs cycle. Step 1. Acetyl CoA adds its 2-carbon fragment to oxaloacetate, a 4-carbon compound. The unstable bond of acetyl CoA is broken as oxaloacetate displaces the coenzyme and attaches to the acetate group. The product is a 6-carbon citrate. CoA is then free to prime another 2-carbon fragment derived from pyruvate. Notice that oxaloacetate is regenerated by the last step of the cycle. Step 2. A molecule of water is removed and another is added back. The net result is the conversion of citrate to its isomer isocitrate. Step 3. The substrate loses a CO2 molecule and the remaining 5-carbon compound is oxidized, reducing NAD+ to NADH. Step 4. This step is catalyzed by the multi-enzyme complex, very similar to the one that converts pyruvate to acetylate CoA. CO2 is lost. The remaining 4-carbon compound is oxidized by the transfer of electrons to NAD+ to form NADH and is then attached to coenzyme A by an unstable bond. Step 5. Substrate-level phosphorylation occurs in this step. CoA is displaced by phosphate group, which is then transferred to GDP to form guanosine triphosphate, GTP. GTP is similar to ATP, which is formed when GTP donates a phosphate group to ADP. Step 6. In another oxidative step, 2 hydrogens are transferred to FAD to form FADH2. Step 7. Bonds in the substrate are rearranged in this step by the addition of a water molecule. Step 8. The last oxidative step produces another molecule of NADH and regenerates oxaloacetate, which accepts a 2-carbon fragment from acetyl CoA for another turn of the cycle. And then the cycle begins again, once again at step 1, and it continues again and again and again and again and again. But it is important, oh so important, to remember that the cycle must go 2 times for every glucose that it's formed. Formed.